Hello everyone. So continuing to GATE course, the lecture series which we have started in the last week. So welcome to Surabhi Academy for Civil Engineers. So in this class, we'll discuss something about the basic concepts and force systems. So when I say the basic concepts, we need to understand what are the assumptions we made normally in engineering mechanics. So they are particle. So a body of infinitely small volume whose mass can be neglected is called a particle. Anything, suppose best example for this you can understand. In our solar system, we have the sun, and around that we have different planets. So all these planets in that infinite universe, the planets are called as particles. So compared to the dimension of the universe, the particle is very, very small. That is the example of particle. In civil engineering structures, any small body in the construction like beams, columns, they are all called as particle. Then the body, the assemblage of number of particles is known as a body. Then rigid body, a rigid body is one in which the positions of the constituent particles do not change under the application of external forces such as the position of particle 1 and 2. Just look at this. If I am having any particle like this, if I am having two positions like 1 and 2 or A and B, whatever it is, if I apply the load after the deformation, even the body may get deformed, but the point 1 and 2, the position of points 1 and 2 will not change. The distance between them will not change. Even though it is changing, it is very negligible. That is known as the rigid body. Actually, in practical, the bodies are not rigid. This is what the figure in. So you can say, first we are having the body here, the points 1 and 2, and after applying the force or force system, the points 1 and 2 or the position of 1 and 2 will not change. So that type of body is known as rigid body. It is an assumption in engineering mechanics. Next, opposite to that, we have deformable body. So it is one in which there is considerable change in the positions of 2 points after the application of force. That is the deformable body. This is the practical actually, in fact. Next, we have mass. The total amount of matter present in a body is known as its mass. The unit of mass is kilogram. I think all of you are knowing this. No need to explain that. Next, there is a difference between mass and weight. So weight is mass into acceleration due to gravity. That's why the people say the weight changes based on the acceleration due to gravity. The weight of any particle on the moon is 1/6 of that on the earth. Suppose if you are having 1 kg in the earth, better you can say, if you are having 6 kg in earth, it will be 1 kg in moon. So 1/6 of the weight. So W is equal to mg in Newton, where g is equal to 9.81 meter per second square. That is the acceleration due to gravity. This is exactly, in fact, 9.80665. That we are rounding it off to 9.81 meter per second square. When we are converting to Newton, kg to kilonewton, normally the people will take g is 10 meter per second square. So that is 1 kg is equal to 1 kg is equal to 10 newtons. They will take the 10 newtons. So next you should know the scalar quantity and vector quantity. Even though you have learnt, please remember that scalar, any object or any physical quantity, you should have both magnitude and direction. And when we say scalar quantity, it is having only magnitude but no direction. When we are going for vector quantity, it will be having both magnitude and direction. Example of them, scalar quantity, time. See, time is having only magnitude, there is no direction. Mass, density, volume. But remember, mass is not having direction, but weight is having direction. Weight is vector quantity, mass is scalar quantity. We have distance, but velocity is with direction. That's why it is vector quantity. So vector, both magnitude and direction. Scalar, only magnitude. Remember, yes, only single thing, that is magnitude. Next, we have continuum. A continuous distribution of molecules in a body without intermolecular space is called continuum. So that are some of the assumptions which we are assuming in engineering mechanics. Next, we'll go to Newton's laws of motion. Newton's first law says that every body continues in state of rest or of uniform motion along a straight line so long as it is under the influence of balanced force system. That means if you are having any object, if you are not applying any force, on this body, if it is in state of rest, it will be keep on in state of rest, or if it is moving, it will be keep on moving in a straight line so long as it is under the influence of the force. So if you apply the force, it may changes its direction or it may move if it is in the rest. If it is moving, it may halt. So that is the force system makes in the Newton's first law. This is what the Newton's first law says. So every body continues in state of rest or of uniform motion along a straight line so long as it is under the influence of force system. Next, we have Newton's second law. This law states that the rate of change of momentum of a body is directly proportional to the impressed force, and it takes place in the direction of force acting in it. So that is what Newton's second law. Next, we have Newton's third law. It is most common law, that is every action it will be having equal and opposite reaction. Everybody knows that. So this is very famous law, Newton's third law. Newton's first, second and third law you need to remember to understand various concepts in engineering. Not only in civil engineering, various concepts are depending on Newton's three laws of motion. Next, we'll go to the force. That are the basic concepts. As I told you in the last class, we need to discuss about basic concepts and force system. Now, if you come to force system, please remember anything or agency which tends to cause the body to move, or which tends to make the body is moving, which tend to make it rest, is known as force. Suppose if I am having any object, if the agency which causes or which makes this body to move in any direction, or the body which is already moving, the force which applies and stops the motion, or causes the motion. So both thing which is happening by an external agency is known as force, which tends to change the state of a body or a particle. So when a force is applied to a body is at rest, the body may remain in the state of rest or it may move in the some velocity. So SI unit of force is Newton. This you should remember. The SI unit of force is in Newton. Next, before going to the force systems, we need to understand what are the elements or the characteristics of a force. So I will tell you what is this. When I say force, it should have these four things very importantly. If it is not having any one of these, that is not called as a force. Suppose if you are going for this, the magnitude. Say, I am writing the force like this. See, this is the horizontal axis. This is the force. When I say it should have how much force is there? That is 10 kilonewton. The magnitude. So it is always, it may be called as the length of the vector represents the magnitude of the force. Then direction, in each direction it is acting. In this case, it is acting upwards with 30 degree inclined with respect to horizontal axis or x-axis. So that is the direction. The line of action, see, this is the line of action. Suppose if you take a mango, if I am having any mango, so if I apply the force in this direction, I will cut this. I will take the knife and I will cut this. When I am cutting this, so the point or the in which direction I am forcing the knife, it will cut. That means the mango will cut. That is the line of action. The line of action along which the force acting. So that is the line of action. Then point of application, the point on which the force is acting. This is the point where the intensity of the force is maximum. So that is, these are called as elements of a force or characteristics of a force. If I want to call any external agency as a force, it has to satisfy these four things. These four things should be included in the force. They are magnitude, direction, line of action, point of application. Next, we need to understand what are the types of force system. We have coplanar and non-coplanar mainly. See, in that coplanar is nothing but if I'm having any plane, the forces which are acting on the same plane are called as coplanar forces. Co is nothing but same. That you remember. Another things you may be familiar with that. Non-coplanar, not on the same plane. Suppose if I'm having a body which is three-dimensional like this. See, if I am writing like this, I'm having 1, 2, 3 dimensions. If I am having one force here and another force here and another force here, these three are force system. Force system is nothing but one or two forces. F1 and F2 are the number of forces. Two or more forces which is including in a particular system is known as force system. If it is acting in only one plane, see F1 and F2, if I say this is coplanar forces, and F1, F2, F3 is a force system, that is non-coplanar or spatial force system. And if you come to coplanar force system, it can be further classified as collinear. As I told you, co is same in line. The forces which are acting in the same plane and in the same line are called as collinear forces. See, F1, F2, F3, the line of action will be same for the forces. I can write like this also. See, number of forces are acting. Suppose if you take an example, if I am having any, suppose the vehicle, the people are moving one by one. One person is standing here and moving, another person moving this person, and another person is moving this person. That is the moving. All the forces are acting in the same line of action. Suppose if you take a tug of war, see, the persons are pulling this. See, this force, they are applying force. Here one side, another side, number of persons are pulling this rope. See, all these forces, one person applying one force, another person applying one more force, that is F1, F2, same line, collinear forces. Concurrent forces, concurrent, that is concentrated at a same point. If I am having any object like this, I am applying various number of forces at a same point. The line of action is different in this case, F1, F2, F3. So line of action is different, but it is acting at the same point, is known as concurrent force. Even the line of action is same, the point is applying is the same thing. So that is even this also. See, suppose if I take the collinear concurrent forces. See, point is also same. All the forces are acting in this directionally. They are in the same line. So collinear, coplanar, collinear, coplanar, collinear, concurrent forces. So then concurrent forces, then parallel forces. Suppose if I am having the forces acting in the same line, same plane, and maybe in the different direction. If they are in the different direction, they can call it as unlike parallel forces, and the forces which are in the same direction, like same plane, same direction, coplanar parallel forces, they are called as like forces. Then in the general or non-coplanar forces also you will be having concurrent forces, parallel forces, non-coplanar, non-parallel forces. So these are the different types of force system, and based on the line of action and also the point of application and the plane on which it is acting. Coplanar, concurrent, that is what the terms you need to understand. You can remember that. So this we can further discuss when we are solving the first problems on forces, and in the next class we can discuss. We have studied the Newton's laws of motion. Now we have the something called as Newton's law of gravitation, parallelogram law, principle of transmissibility, Lami's theorem, or also it is called as triangular law of forces, and we'll solve some numerical problems in the force system. So this is what we'll discuss in the next class. So till then, please take care.